Hi, this is Ricky-san. I'm a Pi consultant. Today I would like to talk about how to improve the Pi interface performance. Why am I talking about that? This is old technology, right? But from my perspective, this is very common. And also it works. It is, although it is old technology, my client are still using it. I think you are using it. So what's wrong with old technology, right? So talking about the topic, right? How to improve the interface performance. I was helping my client because he have skip scan, and I was looking at the logs. The log indicate 50% of the time was skip scan, and then he has data loss from his interface. I guess he did not retrieve all the data necessary from the interface, right? That's why we want to improve the performance now, right? And you notice I talk about a lot of performance. I guess performance is not just getting it to work, but also getting it to work well, right? So there are 7 ways to increase the Pi interface performance, and the most common problem we encounter is we might have too many tags in our Pi interface, right? My client may have 50,000 tags in one instance with one interface, right? 50,000 tags, but the good rule of thumb, right, from documentation in OSI now, AVEVA, say you can only have 5k tags to 10k tags in one instance of the Pi interface. So what do we need to do, right? If you have 50,000 tags, we are gonna have more instances of the Pi interface with the same point source with different interface ID, right? We can do that, or we can use different point source. It's up to you, but different interface ID will allow you to keep the same point source, right? So point source is kind of like an indicator for your tags on where it came from, right? So we utilize that, and of course there are many other ways to do it, and what I said now may not be an exhaustive list of every single situation, right? And this is just my opinion and the common one too. So if you split your interface instance from, maybe you will first have one with 50,000 tags, then you have 5 after. Then 1 to 5 becomes 10,000 tags each instance, right? I think that's the easiest way to increase your interface performance, by splitting up your interface load to less than 10k tag each. The next way to improve performance is to utilize your scan frequency. In your tag, it is location number 4, right? So you can make your interface scan at different time, right? Some sensors might be pulling data every hour. Then you don't want to scan every second, right? Because it's not going to change, right? Or sometimes it is like change once per day. Then you don't want to do a 1 hour still, right? It just, the scan is correspond to your piece of equipment, and if they don't scan that fast, then you don't need to scan that fast, right? So scan frequency, you can split your load accordingly according to the sensors, right? Or of course there is scenario that is necessary to scan once per second, but it's rarely do that. But people like to see every second data. I know that. You can do that too, but you need a lot of interface instance then, right? Because you're going to overload your interface. Yeah, so scan at the different time, right? Scan at a different time will help you spread the load as well. You don't have to create different instance of the Pi interface like the one I talked about before. And then we can do one more here. Utilize your scan offset, right? There's a clock, right? Imagine you have a clock. You can scan some at the top here, and then 10 seconds, and then 50 seconds, and then in the clock is 60 seconds. So, you can utilize the offset to make your scan at different time as well. I guess the fourth improvement option, in my opinion, is to optimize the data source, right? You can look at, for example, you can look at a database, an interface from RDBMS, right? Pi in RDBMS interface. Look at the data from a relational database. And you could optimize your query so that it retrieves data faster, right? Like if it is like, I don't know, join, you have so many join, and then it retrieves like, I don't know, you need 1 minute to retrieve, then you are going to wait 1 minute before you get the data, right? So that's kind of like what I mean. You have to optimize your data source in order to increase the performance. And you can also move closer to your data source as well. Sometimes, there is network latency between, I think there might be long distance going on, right? You have to go through, if data source and your Pi interface are not in the same place, then expect the latency between that, so that, if you can shorten that, right? Like if you can bring the Pi interface over, then your network latency become less, and there's next to none. Then collect the data and then utilize the buffer, send data, right? Then the data retrieval time will be the same, right? And also it's easier for you to configure too. If you install it locally on your data source, right? Your Pi interface on your data source, then security problem is removed, like DCOM, like when you try to remote access your OPC data by an interface, let's say Pi interface or OPC DA, and then you will hit DCOM issue, right? And when you install it locally, you don't have that issue. And all issue is IT. You can ask IT to open a firewall port 5450 so that it send data to Pi from your OPC server from the Pi interface, right? So that will eliminate a lot of problems if you install locally on the data source. And talking about more option to increase the performance, you can enable your compression and exception. I know, sometimes you like to store 1 second data into your Pi data archive. I did it many times previously. Now I only do that for my test tag, right? And if you do that, right, then you are storing a lot of unnecessary data because you are storing everything in your data archive, right, in each scan. So it affects the performance as well. And like imagine you have a trend, right? It's kind of like flat line, but I'm not talking about the data is connection loss or anything. I'm talking about is store the same data over and over again. Let's say it's a 1, then like 1, 1, 1, 1, 1, right? And then imagine it store every second, then every second you get a 1. So are these necessary? Maybe, right? It's based on your requirement, right? But many times it's not the case. Then if it is not the case, don't try to store all the data into the data archive. It's heavy for your interface, it's heavy for your data archive, right? The performance will decrease. and you will see a performance increase if you just turn on the compression exception. Lastly is to increase the CPU and memory. I had the issue of starting an interface up. Like let's say you press on the start button on your Pi interface configuration utility, and then you wait like, oh, why is not getting an update? Like, and you look back like half an hour, it's not changing, and then like 1 hour, not changing, and then finally, oh, like suddenly, like after 1 hour and a half, you see data, like one data updating. And then, you know, if there's too many tags in the interface, it takes a long time to load everything into memory and then start data collection. So if you have more CPU and memory, then this will shorten. This time will be shortened because your startup time will be changed from 1.5 hours to like 15 minutes, right? I remember I was asking the IT person help us increase double the memory and double the CPU as well, and then we see that different. So memory and CPU are also important, even though it did not fully utilize your CPU and memory. Like when you look at it, like start and then you wait, it's not going to like hit the glass ceiling saying, oh, 100% CPU and memory. But you know, if you have more, the interface will run faster. Yeah, so that's all I wanted to share for how to improve your interface performance, Pi interface of performance. Thank you for watching. Please don't forget to subscribe as well as hitting the bell icon. I'll see you next week. Bye.